Welcome back. Let's talk some scallopy things, shall we? Surprise, surprise. So as our speakers were presenting earlier, one thing that occurred to me, just as maybe a way to cue this up, is that we're listening to a mixture of techniques which range from a fishing technique, spat collection, and Marcin Brewer had many years ago explained this to me, that this is fishermen doing fishing work. They're fishing for larvae. And parenthetically, it took Maine fishermen precisely 1 year to get really good at spat collection. So try a new thing. Nothing like working with a fisherman to learn how to catch something. They had it pretty well wired by year 2. Yeah. And so the beginning of some of these processes begins with spat collection, which is a fishing technique. And then you kind of range into a spectrum of overlapping fishing and farming techniques, which I kind of find interesting. And it's a unusual juxtaposition of cultures, backgrounds, activities, all in support of this goal of enhancement. So just an observation, maybe to get us thinking a little bit. We have about an hour. And as I mentioned earlier, there are decades worth of experience here. So please press them. And who has the floor first? Who's got a question? Somebody has to have a question. Yes, please.
Thank you. And I believe my question is directed to Leslie Ann. Your last comments you made were in regards to fuzzy rope spat collection. Can you expound on that a little bit? Because it sounds as though something you could deploy in the water and then move it to an area and allow it to settle and allow those spat to release from that fuzzy rope and populate an area with scallops without the elevator consequence of bringing them up to the surface and putting them on a boat and moving them, that you could just move them while they're in the water, basically. Possibly.
Yeah, the idea came to me from the New Zealanders. They tried it first. And also the idea came to me because everywhere we did have spat bags underneath, like when we use the same site for many years, underneath the spat bags, it seems to increase the population of scallops. So it came like, okay, that means there are scallops falling off from the bags. And in New Zealand, the idea is to put these fuzzy ropes that would attract the spat. When they're in suspension, they're 6 feet off the bottom, they're safe from most predators. But then as they get heavier, and they fall to the bottom, but then now they're bigger and they can swim away from the predators. So we call that a passive enhancement. Also, it just gives them a place to settle, because in nature, when they're settling, they're looking for something to attach.
In the literature, they'll say they attach to various different things that are on the bottom. But if they can't find any place to attach, they get carried away to the current and they die. So this is giving them a place to attach.
So as a follow-up, the spat collectors currently, what material are they made out of? Do you know? And this is for anybody.
Well, the material that
the outer bag seems to be some kind of nylon plastic, and what we put inside was Netron. That's worked the best, but actually almost anything worked. We tried monofilament, like old monofilament. We tried fuzzy ropes, and you probably tried a whole bunch of other things. But what we liked about the Netron is they're easily washed and they were reusable. So we could use the same Netron year after year.
Yeah, a lot of the docks have a lot of rope, big hawser rope, hanging around, just doing nothing, and just, yeah, it needs to be recycled, and that would be a very innovative way to give it a second life, and then somehow retrieving it from water. Thank you.
I'm going to try to riff on this a little bit and ask our Japanese experts, Hamano-san and Dr. Kosaka. In Aomori and in Hokkaido, there are big loops of like gillnet used for passive collectors. Kind of like what you're talking about, perhaps. They just use gillnet, and I'm wondering if you could speak a little bit about how those passive collectors work in the Japanese enhancement efforts.
Don't have to. They just put like something there, attached to them, grow, and then fall to the bottom. So you didn't have to do any work to put them on the bottom. They did it on their own. So what he said that you do that.
It was old gillnet, and the gillnet loops may be 8 feet tall.
The gillnet spot collector is used in Funka Bay, where lots of sea stars in the water. So if you put outer bark outside of gillnet, sea stars comes into the spot collector and they eat them up. The spot eat everything.
Juvenile sister, not birth correct. This when juvenile sister on the not correct and at night inside sister juvenile eat scalp spot. One day juvenile sister eat 100 spots. We previously second hand gillnet for summer very cheap. But even now, I cannot get a second hand gillnet for summer. We use a new gillnet for the flatfish and cut and use for the use gillnet for the inside collector. In Hokkaido, Funka Bay, long gillnet. If the fishermen in Funkawa outside use outside net back on the knot of collector sister into the back easily. Fishermen in Hokkaido not use the outback collector, not use fishermen in Mutsu Bay use the outside back because of the sister very few. Okay.
Yep.
Hello, yeah, I had a question for Kay and Dr. Kosaka. I'm just really curious to learn a little bit more about your predator removal strategies and whether or not it was a little unclear to me, you're just monitoring for areas with fewer predators and fewer sea stars, or if you're actively going in and removing the sea stars and other predators or competition like the tunicates. And if so, like if you could provide any information about maybe the percent abundance or like total numbers of predators that you're actually removing?
We are survey our larva and spot every week. We are density of sister larvae. If our sister larvae are many, a lot of sister, we watch this outside back washed and for the sister juvenile sister fall down and just on the seabed.
And Andrew, was your question about adult sea stars on the bottom as well?
Yes, yeah.
Yes. So adult sea stars on the seabed, could you speak about how, if you control them and how you control them?
Fishermen in Mutube catch starfish with duet or sister mob. We get all sister, adult sister artery. There is isn't sister in Mutube, no sister. But Funko Bay, in the Funko Bay, there is many sisters on the seabed. But Funko Bay, depths of the Funko Bay deeper than in Mutsu Bay. Cannot fish in Funko Bay cannot artery sister.
So in Hokkaido, local governments pay a subsidy to local fishing co-op to remove sea stars. And then actually it's kind of like the local governments buy sea stars. It's like if fishermen get starfish a lot, they get money. Usually barn, but you need fossil fuel to burn them out. It's wet and it takes so much time to burn them out. So these days, like Chinese buyers buy sea stars. I don't know how they are used, but you know, it's kind of lucky.
Oh.
Yeah, Hokkaido fishermen told me.
We used previously food fertilizer or apple fertilizer.
Could you repeat that and speak up a little, please?
I was curious if the government pays money for the removal of any other adult predators, or if it's just sea stars that they're mostly interested in.
Predator for the scalp is the octopus, big octopus. Japanese octopus prey on the Japanese scalp, many Japanese scalp. But octopus and body.
Yeah. Yes, I was going to talk about this tomorrow, about the predation. You know, the scalp sewing fishing ground could be a good fishing ground for octopus. So Japanese buyers buys octopus with very high price. So, you know, fisherman makes other money from removing predators.
In the back, please.
Yeah, I had a question for Leslie Ann in the Scala Hotel California that you had. It seems to be like a little bit different, the way you guys are talking about spat collection compared to how the Japanese gentlemen were doing it. Seems like they're collecting spat and bringing it back and raising it to a certain size and then deploying it again versus methods you guys were using that it looked to me like you're growing them in, you're really doing that that growing period in the bags themselves. And then you're just deploying them directly from the bags there. So there's not that sort of middle part of the process. There's just spat collection, and then the initial sort of grow out happens in the bags. And then you just deploy them on the bottom. Can you talk a little bit about the timelines for that again?
Yes, awesome.
We deployed the collectors 4 weeks after the initial spawning, which is usually happen at the end of August, so it would be the end of September. And then we'd leave them there for a whole year, mainly because we didn't have much money. And, but I know in other areas, they would able to bring them up a lot sooner and then, like you say, sort them out, put them in nets and grow them. And for them, it was more efficient. But for us, because of lack of funding, we left them there. And we never went back till the following year when the air temperature was below 10 degrees. Because we found that when the air temperature is warm, they die quickly. But we also wanted to make sure it's done before the air temperature freezes. So we always tried to look for the right temperature between 5 degrees and 10 degrees before we handle our scallops, because when we handled them, when the air temperature was at that point, we had very little mortality, like less than 2%. And even for transportation, like we often would, if we had to transport from one area to another, we could just put the bags in, make sure they stayed humid. Like we didn't have to keep them in water. We just kept them humid and would transport them. And we had very, very little mortality. It wasn't an issue, but we had to make sure the air temperature was between lower than 10, usually between 5 and 10 is what we did. And then we would clean them, sort them. We got rid of the starfish, and then we'd put everything on the bottom because the hyatellas and the mussels, they didn't survive on the bottom because they're too deep for them. So we didn't worry about it. We just worried about the starfish and also the rock crabs. We worried about them. We took them out.
And I'm going to ask Marcin to talk a little bit about transporting spat bag and seed, because you've got 20 odd years worth here. Thanks.
For moving the seed around, well, when we sell a live scallop, okay, we'll pack it up and get it in a cooler before the sun comes up. We start early in the morning. And then we have it to Portland to market by noontime. It's got a 5-day window on it. Needs to be gone at the end of 5 days. So that gives the customer as much time on them as we can. What we do is we put them in 5-day coolers, you know, the ones that keep cold good. And we'll take just like a small handful of seaweed and put it in a scallop bag. First couple of years, we just put a little bit of seaweed on top of them, but we found out we weren't supposed to. But anyway, but that's what we do. It's kind of like when you put an ice pack on your leg. You don't put a towel on it. You're apt to burn your skin a little bit. So, you know, it's just getting them the cold, but insulating them from too much cold. And we transported them around 90-degree weather. Had them in those coolers all day, brought them back because they got way too many in an order and it was over 90 degrees that day. We put them off in separate nets when we brought them back so we could see what the damage was. And I lost 2 scallops out of the whole work. So, you know, they're not bulletproof by any means. The air temperature will get them. You know, but then we use ice packs on top of them. Reusable ice packs so that we can keep them cold. But I was just talking to a guy from New Hampshire and they took them for what, 5 hours and didn't have any problem. You know, a little knife in, so. But you gotta really pay attention to them. They're not gravel or oysters or mussels. They're pretty sensitive.
How about for transporting? How about for transporting spat? If you're moving them from one place to the other, recommendations there?
Yeah, we'll bring them in the end of October. See, our season's different than over in Japan because they're collecting this spat in the spring. And they got that whole summer's growth on it, so they got a pretty good product come the end of the summer. We're collecting them in September. So over the winter, they don't grow a whole hell of a lot. So we've got them in the bags for, 8 months before we take them out. We tried going all summer, like what Leslie Ann did. And we had some of the biggest, healthiest starfish you've ever seen. Weren't they fat? We had about 90% mortality.
Thanks, Marcia. Oh, yes, please.
This is basic processing of scalp culture. In the spring, collect developed in spring, and in summer, July to August, spot are collected, put in the pernet. Mesh size is about 5 millimeter to 7 millimeter. Next, I called intermediate culture for hand culture from July to next January or February. But intermediate culture for sewing culture, January to next spring, we call it intermediate culture for the sewing culture. Intermediate culture for sewing culture, after that, the young scalp are released to bottom next spring. We call our intermediate culture. It's important process for scalp culture.
Thank you. Is everybody catching that?
I'll explain a bit. The important key number is like 4 centimeter, because it's for sea stars, it's really hard to get, hard to eat like sold scallops on the seabed. So if that scallops were sold like less than like 4 centimeter, the scallops get eaten by sea stars. So in Funka Bay, the fishermen like collect spots with the size of 1 millimeter and then put into poly nets and grows it to 4 centimeter using poly nets, and then and then transplant it. Like,
sorry, our scalp size is this is about 5 millimeter to 7 millimeter. In this season, the size of the scalp is 5 centimeter. And so in culture, scallops. The size of the sewing culture is 5 centimeter. Price of the about 3 to 5 M. One individual.
I-
Sorry.
Sorry, I had my hand up for a while. I'd like to get back to Leslie Ann again. I'm intrigued about your leaving your collection nets on the bottom for a year. We heard earlier today that you have to monitor your collection nets for fouling, loss of gear, things like that. In your experience in Canada, I know you're fishing, you're collecting a little further. Do any collections on Georges Bank that would be comparable to what we would need in this fishery, in the U.S. fishery?
No, we didn't do any collection on Georges Bank because the fishermen there are in the maritime region and they were not interested in it. But what we had done several studies where the timing of our collectors, so we wouldn't not also get sea star, because sometimes you might get less scallops but no sea star. So you'd select that day instead of the week before, because the sea star, they actually settle a few days or a week before the scallops. So if you're timing it, so we did a few studies for the timing. So we would reduce the number of sea star. Every once in a while, there would be a sea star, and yes, they would be one fat sea star and no scallops. But you just have to deploy them later. But I just wanted to add, we did also some transportation at non-ideal time because the air temperature was warmer, and we used the very same technique as Marsden, but with the fishermen that I was working with in the Northumberland Strait or Bay de Chaleur, we had like 8,000 collectors. So that many collectors, you can't put your ice packs, or it's just too many. So there's different ways of dealing it as long as you can protect the scallops from the warmer temperature. And like what he did, he had them in insulated containers so that it works. But what you're going to do is going to depend on how many you have, right? So.
My original question, do you experience any fouling of your collection nets?
Yeah, at the beginning, yes, at the beginning we had fouling, we had gear loss, we had all the problems you can imagine. But after a while of trial and error, we figured out what depth is the best for the least amount of fouling, what depth is, what area is the best for the least amount of problems of losing your gear. And those anchors, I could show you a picture later on, really helped to prevent loss of gears. So there was a lot of trial and error before we actually became successful in what we were doing. But I don't think it would take you guys that long because you're already into it. So it would just, and you don't have to do large scale at the beginning. You could do small scales, figure it out for your area, and then you can do larger scales.
That's very helpful. I mean, as long as we can find a spot where fouling is not an issue, long-term soak would be probably doable. I appreciate that. I neglected to announce who I was. My name is Eric Hansen. I'm a lifetime fisherman. Currently, the last 20 years plus, I've been part of the scientific collection, and more recently, I'm part of management. Thank you.
Thank you, Eric. As someone who's done a little bit of this work, but also watched a lot of other investigators do, like Phoebe and Carla's work, ocean's a big place and they're all different, and you can do models and you can make predictions, but the rubber really meets the road when you, just as you know, as a fisherman, a lot better than me, you got to get out there and do it. And that's both daunting and exciting at the same time. Having heard the success that you had just blew my mind. So it's really exciting to think about those possibilities. Sorry. Carla, were you next? David, sorry.
Hey, I'm gonna give Farrell a question. Looks like he's waiting for one up there. You talked about location, 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 and I agree with you. I think that's something that, we observe in the wild resource a lot in terms of productivity, where some areas are more productive than others. In your transplanting experiments over the years, and I guess this would kind of apply to other folks too when they talk about site selection. What kind of criteria did you use to try to optimize or even consider differential habitat characteristics with respect to where you might place scallops? Because I think if this moves forward in terms of that context, this is going to be a very critically important component of any plan.
So, so I guess I for the work that we did in the Nantucket Lightship area, it was based off of what fishermen had told us were historically productive region. Our more recent work, we used our site selection was based off of the maps that I think Kevin Stokesbury and Bradley Harris had produced of the Georges Bank region, looking at sediment stability, sediment type, and historically where scallops had been in the closed area 1 area. Because we know in the shallower part of closed area 1, there had been historical sets of scallops, and now what we're seeing is a deeper set. But I guess the question then comes, what conditions change to prevent scallops from recruiting there now? And if we're moving them there, is that an indicator that they would be more successful, or have the conditions changed overall together to prevent adult scallops from growing out? I think one of the things that would be useful for site selection going forward, and I think people are investigating this, is the habitat suitability models that have been done with Daphne Monroe's group, and I think Rubio Jai, kind of looking at how the population will change in the future, but instead of looking at larval recruitment, maybe looking at scallop growth and kind of looking at areas that could, with those models, that will sustain growth in the future for scallops, and then might be able to transplant them there, especially in the Mid-Atlantic. If in the Mid-Atlantic, if we assume that the bottleneck is related to larval recruitment, it doesn't necessarily mean that that habitat is no longer viable for a juvenile or adult scallop. So we could still possibly transplant sea scallops down there. So I think modeling has a good approach to trying to select areas. Our work has been based off of historical knowledge and a little bit of kind of using the modeling stuff that Kevin had done to identify habitat suitability for sea scallops. I think Ron also, when he did the seaside site, that was again historically from what fishermen had told him, that scallops had set up there in the past. They just hadn't seen recruitment. And I think Richard Taylor, in terms of spat collection, had done some work kind of going back. One of the things that he had noticed was that instead of using brand new gillnet monofilament, they had actually used older gillnet monofilament material, and they speculated they had better recruitment with the older material, and they had kind of speculated that it was either rougher, maybe the texture, but also some of the fouling that had died and dried up might have also encouraged settlement in those bags. But I think one thing that would be interesting to do is to try to link a larval spat index to where scallops recruit, and then kind of try to find areas where we could supplement where historically they recruited to. We're not seeing a larval supply, but we know there's variation, and maybe just put scallops in those areas because we know they're healthy, at least for settlement. But I hope that answers the question.
Yeah, thank you. Carla, you were next, and then David, I think. All right.
Hi, thank you. My question's for Leslie Ann. I appreciate all of your hard work in the Northumberland Strait and throughout Eastern Canada there. With that said, I understand the budgetary constraints of processing, because we're definitely hitting it with our, 56 some odd collectors that we have out. And I'm wondering if you ever processed a select few of them to, like earlier, you collected bags and counted how many scallops you had, and then, just settled on your October date later to release those scallops. Do you know what your sort of losses were between an earlier time and a later time?
Yes, we'd always do a check, like we'd put them out and then we retrieve some and do a check. So there was from the fall to the spring, there was a big loss, but our goal was to end up with 2,000 per bag. So yeah, you have a big loss but then in my mind, it wasn't a big loss because I imagined them falling through the collectors and going on the bottom and seeding the bottom naturally. So yeah.
Okay, thank you. Because that's, we have some right now that have been growing in their bags the whole season. We haven't been able to tend them at all. So I think actually just today, I'm getting pictures of some bags being sent to me being cleaned up. So it's pretty exciting, but that definitely a lot of loss we had from the densities we had back in April.
Yeah, because when they're very dense, there's hardly any growth. And like you can take them out earlier and spread them out in other growing techniques like the Japanese techniques, and it works well. But if you leave them dense, you're going to have a lot of loss. It's just there's not enough food for them, right?
Thanks.
I had one other, you presented data on the proportion of those you released in the wild fishery, right? Did I see
No,
that?
the data that I presented was from the Magdalene Islands,
Okay.
and they had followed it closely. Yes.
And how did they mark it? How did you know the difference?
Well, they knew the difference. Same idea as I think the Japanese knew the difference. I think it was the Japanese where there was a mark on
French,
the
yeah.
shell, so that's how they knew the difference.
Okay, thank you.
All right. Thanks, Carla. David, please.
Great. Thank you very much. David Bethany, Commercial Fisheries Research Foundation. And thank you all for sharing your knowledge with us today. I also had a question for Leslie Ann. So you showed significant success restoring depleted scallop beds, but then in the end, you mentioned there was pushback from managers and fishermen not to adapt or change to continue enhancement. So could you talk more about what happened at the end there?
At the end, the fishermen were given the choice of making it part of their management strategy, and they just didn't want to have it. They didn't want to change because it's one in our area. It's one fisherman, one boat, and to really be successful, you have to work cooperatively, and nobody wanted to do that.
Yeah, please, Mark. Thanks.
So I think this is kind of the beginning of Dave Rudder's question. We're talking about finding areas that maybe they're recruiting but aren't going to be successful grow out areas. But I'm curious if there's also places that are recruiting that fishermen may not have access to, particularly as we develop more user conflicts, and if there could be a strategy to move animals from those places to places where you're going to get more access to the fishermen and maybe to grow out. I think, Farrell, you probably have looked at some of those things.
Yeah, so we are starting to kind of look at how potentially recruitment within wind energy areas and whether the fishery may or may not be allowed to operate in those areas. And it might not be that the wind companies directly tell the fishing groups that they can't participate. It might be the insurance company or even the Coast Guard. We have, like, Ron is an engineer, so he has been brainstorming and thinking of ways to possibly harvest scallops from within a wind turbine area that would not impact the infrastructure in that area, and then possibly transporting them out of those areas. I think I talked to Wes Brighton earlier. One of our ideas is kind of using cottons with remote releases and an acoustic release, so that way we'd never have to actually bring the scallops onto the deck. We could just tow the net from one area outside possibly of a wind turbine and then release the scallops on the seafloor where they're able to be harvested by the fishery. But that would also take kind of getting the wind companies and communicating with them the need to potentially have a solution for high recruitment within their wind areas and how they want to respond and pay for it, or what mechanisms to do it.
Hi, I'm Essie. I'm with Vertical Bay. And I had a question for you, Farrell. It was a methods question. So that movement study that you showed with the time lapse, what size were those scallops that you used in that study?
They were on average, I want to say 86 millimeters was the shell height from what we took. They were from closed area 1. So that site, that tech, we did it in 2 sites. So that would technically be our control area. So that's that time lapse that I showed was the origin site. And what we wanted to do is kind of compare what we saw at the harvest site to what we saw at the transplanting site. I do have the video from the transplanting site where we saw moon snail predation, but they were all about 89 millimeters. There's a pretty good recruitment event there. There's 2-year classes. Last time we were out there, there's another size that's slightly smaller that we avoid tagging and transplanting, because what we've kind of found out from our work, and I think some of the other work that has been done is similar, is the optimal size is about the diameter of a Coke can is kind of what we're looking for to transplant. Anything smaller seems to be a little bit more sensitive to the transplanting pressure or transplanting mortality, as well as potential predation in the area. And I think around 75 millimeters, they're able to kind of avoid predators and recover better from the shock of being moved. So yeah, that's another big problem. Yeah, when they are smaller, about the $half size, they are a bit fragile. I know when with the Nantucket lightship scallops, those ones actually had a general more fragile shell. I think in addition to calling them Peter Pan scallops, I was calling them Pringle scallops because their shells were like. So that was why in that area too, we were really focusing on using trawl nets versus traditional scallop dredges, because we felt the mesh would be a lot better at kind of protecting the scallops from that area. But yeah, Devorah, you're right. The smaller scallops too are a little bit, their shells just crack. And they also seem to separate from their hinges a little bit.
Thank you.
Those fishermen was kind of hinting about out to George's. And Richard Taylor, like you said, did some work out there. And he come up to the house one night. I drove from Gloucester up to Stonington. And we talked about spat collection. And Leslie Ann had a sheet a slide that really showed a whole bunch of scallops between 2 land masses. And they tried to catch them in spat bags and they couldn't. And what I've noticed is we do all of our setting on the mud, because if they land in that mud, they're dead anyway. So we're taking stuff that's not gonna make it, for starters, and we're turning in something good. But in looking on where to set spat bags, that's a real big piece of it. Is not trying to compete with natural bottom, because you can't. And your bags last a lot longer out over the mud, because they don't get tore up with rocks and shit. So anyway, just want to share that with you.
Thanks, Martin.
Japanese contingent as well. So you mentioned that you taught the Chinese how to do this, and now they are very prolific. So what were they doing before? Had they had a fishery that collapsed, or did you show them how to create a new fishery? And are they using the same techniques that you're using now?
Chinese didn't product scalp, no scalp. Oh, after that, we are taught the Chinese here product a scalp. Base scalp imported to China. Dr. Chu, Washington University. He take a Chinese 5 base scalp. Yeah, American base scalp.
And are they using exactly the same methods that you use?
No, well, method of corrector and intermediate layering and lanternette.
Hugh Copperthwaite, Coastal Enterprises. Kei-san and Kosaka-san, I was wondering if you could talk about the use of pearl nets specifically and just get into that a little bit, like the design of the net, why it's used for juvenile scallops. As opposed to just going from a collector to, say, a lantern net. I realize there's mesh size is definitely smaller on the pearl nets, but if you could just elaborate on the use of pearl nets on the long line and the reasons for that.
For example, in the correction stage, mesh size is smaller than size of scalp spot, about 1-2 millimeters smaller. And what I'm saying, the net, the film left side is smaller than the size of scalp, 1 or 2 millimeter. Our lantern net is used for the adult scalp culture. But our net made of monofilament, monofilament give a damaged scalp easily. But pearl nets are made of not monofilament. Monofilament, no monofilament net didn't damage the scalp. But by falling, attached on many by falling attached on this pearl net.
Hello. I was hoping to get a little bit of clarification on why I'm coming from more of an aquaculture perspective. So I was curious as to why um it seems like a lot more work to seed them on the bottom. Do they just grow faster or better on the bottom? Why not just keep them in the lantern nets and go like full aquaculture? Well, not full aquaculture, but
At least in our project, the reason why we did that is because once they're on the bottom, there's no more work. You just wait your 4 years, then you can harvest. And you can do a lot larger numbers, like while in culture, you're limited with the amount of gear that you have, and you're limited with the amount of space where you could put your gear.
In the lantern net is a much white product because of depth shallow. Bottom culture is scalped, eating many, doesn't eat many plankton because white plankton is few. The depth is deeper, not lay into the bottom, oh, the phytoplankton produced, not product on the bottom. Bottom culture scallops isn't eat doesn't eat white plankton easily.
So they don't need as much plankton, is what you're saying. Therefore,
So for sowing culture, it takes 4 to 5 years to reach a commercial size. But hanging culture, it takes only like 2 years. It grows really faster. Maybe Jana, Andrew could explain that.
Time to market for.
So yeah, basically this is Andrew from Vertical Bay. The biggest difference between a bottom culture and then kind of doing a or a sowing culture and then versus a like a ear hanging or a lantern net grow out is you're basically at that after that first year of kind of nursery rearing, you're either sowing or then you're continuing to grow in nets or ear hanging. And that, if you're sowing, you're just putting them on the bottom and you wait 2 or 3 years. Versus lantern nets or ear hanging, there's just an incredible amount of labor that goes into growing the scallops for the next, even just 1 year. They grow faster. You get, like Phoebe's work said, you get a meteor product. But that represents, yeah, a lot of money that's input. So even if they're on, you're spending a lot of time, money to ear hang the scallops, they grow faster even than lantern nets slightly. You still have to go back and clean them, 2, 3, 4 times in that year that they're harvested due to the biofouling. They're up in the water column, so they're up in warmer water. So there's more stuff growing on the scallops, on the dropper lines themselves. So then you just have to keep up on cleaning them. So it's, yeah, just a
it's a
trade-off.
time and a labor thing.
Yes, yeah, and the scale. So also from a space perspective, you're having to thin out the scallops. So on say one 800-foot long line, you can have 100,000 market size scallops versus on that same 800-foot long line. If you're doing bottom sowing culture, you're growing them in those pearl nets the first year, you might be able to have 500,000 to, depending on your stocking densities, you might be able to have 1 million scallops on that 800-foot long line. And then you then sow them onto the bottom. And even if you get 30% or 70% mortality, your input is less and you're basically winning the economic struggle.
Gotcha. Thank you. That helps a lot.
I would like to add real quick, one of the reasons too we were looking at a transplanting, at least from our end, is that from the commercial fisheries perspective, from the wild harvest guys, it's one of the faster ways. It would require the least amount of investment on their part to transition to a transplanting model than using aquaculture gear. A lot of the scallop vessels, they wouldn't need to buy any additional things. And from the transportation standpoint, they have the fish holds and the ice and the capability. So in terms of bottom sowing, to take like a limited access vessel and go out and bottom sow it, it just becomes an investment of their time at that point and no investment in additional gear. So it'd be one of the faster ways for the current fishery to transition.
Toad just wanted me to point out the number of times that we handle a scallop from spat collecting to harvesting. And in our process, it's upwards of 10 times of handling an individual scallop, individually, with our hands. So versus, doing a sowing culture or a stock enhancement, essentially culture, you're only handling, you're emptying the spat bag, you're doing maybe 1 or 2 pearl net thinnings. So you're handling, 2 or 3 times. And then that final harvest is with a dredge. So.
And I'll bring us back a little bit to the economics of it. So, oh, I'm sorry. Please, go ahead.
We developed the facility and agriculture techniques, but in the calm bay, like a calm bay, we culture, agriculture easily, but in the open sea, strong wave broken facility, fishermen facility, fishermen culture in the open sea. It's impossible. For example, fishermen in Hotsku hoped to agriculture, but it's impossible. Here, instead of agriculture, here carry out sowing culture in a host area. Okay?
Mother Nature calls the tune. Yes, please, David.
Yes, I've got a question about spat collection in Japan. So it was my understanding that in a good year, you might collect billions of spat. What happens to the ones that don't get collected? I'm wondering, I mean, we talked this morning a little bit. I think there was a question about, is there a wild fishery? Are there other stock portions of the stock that are outside kind of the realm of the culture operations? And so I'm just wondering, A, where do the excess larvae go that don't get captured by the spat collectors? And where are the larvae coming from? Are they coming from only the animals that are in culture, either sown on the bottom or in more aquaculture type systems?
For example, Musube, fishermen hold commercial size scalp. This commercial size is adult scalps. Total adult scalp is 100 million in Mutsube. Eggs and larvae go out from the Mutsube, don't go out from Mutsube. Larvae and swimming in the Mutsube, only in Mutsube. The change rate or current is 1 month or 1 month half. Or in West Bay. In East Bay, current change rate is 3 months, very slow moving and circulation. And larvae doesn't go out from Mutsube.
My colleagues in Magdalen Island showed that some of the wild spat that didn't get caught also settled on the fishing beds. But as Marsden said, if the spat happens to be settling on a mud bottom, there's nowhere to settle on. They need something to attach to. So if there's settling, and they're carried by the current, they can swim a little, but they are very vulnerable to the currents. And if they get caught in a current and eddy, and it happens to fall on a muddy bottom, the only conclusion I come to is that they die.
All right. Well, thank you so much. This has been a great panel. I love hearing about this stuff because it's such at the intersection of what the fishing industry and the aquaculture industry brings to this by way of their hard-earned expertise and the things that we need to know from the science end. Where are the parents? Where are the spawners? What are the influences of currents and tides and oceanographic information? And when you put all this stuff together, then we begin to develop answers and together to gather a better understanding of the whole picture needed for success. So please help me thank the panel again, and thank you for your questions.